In this last video, we're going to loop back through some of the experiments and observational studies that we saw before and try to figure out what statistical tests we're using and what kind of claims we can make. In this first one, we had a student group of students on the college campus, and they surveyed people before and after an advertising campaign to see if it made a difference. We decided that this was an observational study. Now we need to figure out what kind of claim we can make. Since it's not an experiment, we cannot claim what causes what. But what we could claim is that the advertising campaign somehow may have been linked, potentially, to our results. Let's imagine that we found there was a significant difference between the proportion of students that had been to the new restaurant at the end and the proportion that had been there before the advertising campaign. The claim we could make then is that the proportion of students, I'm going to write this out, the proportion of students who have been, and I'm not saying why, who have been to the new restaurant increased during the same time period as the advertising campaign. Or you could say, while the advertising campaign was going on, the proportion of students who came to the new restaurant increased. The important part is to not attribute why this happened, because we don't really know. If we ran a proper experiment, we might be able to determine why. In this case, we can assume that perhaps it was the advertising campaign, but we have no statistical proof. So when we make our claim, we might say anything to the effect of linking the two. Proportion of students who went to the new restaurant went up. It happened at the same time as the ad campaign. We're therefore thinking that it was probably the ad campaign, but again, we cannot prove it. So be careful with your claims. Don't overstate them. Next example, we had an experiment here. Math department wants to know if students perform better or worse on tests when they're listening to music. Half the students that volunteer are going to listen to music during the test. The other half are going to have no music. And we want to see how those results compare. We can look at since this is an experiment here, we can look at an explanatory variable, our two treatments, and they're going to be music and no music. So those are the two treatments that we have. The explanatory variable being whether or not they're listening to music. The response variable, what we're actually measuring in this study, is the scores after the test. We're comparing the resulting scores after they complete this test. So the response variable would be test scores. Now, as far as figuring out if each of these are categorical or quantitative, since these are two options here, these are two treatment groups, non-numeric, we're going to say that this is categorical. Test scores are going to be a number, so they're going to be quantitative. Now, categorical and quantitative paired up together, we're thinking Unit 5, the different tests available to us. There's exactly two treatment groups, and it says nothing about matched pairs. It's two separate students that are in taking the test with music, taking the test without music, not the same student taking it twice. So there's no matched pairs, and there are exactly two treatment groups. So that means that the comparison test that we're going to be using is the two-sample t-test. Two-sample t-test will be the calculator test that we'll soon use to do our analysis. And then finally the claim. Let's say that this two-sample t-test comes out to say there is a significant difference between these groups. And let's say that the music group performs better. Then we can say, in this classroom, let's say, let's be specific to this teacher. Let's say it's Mr. Pedon's classroom. Students performed better. Students performed better on a test, let's say a unit test, while listening to music. And more specifically, not only did they perform better, but let's talk about the causation. Music caused, or listening to music, caused students to perform better on a unit test. So the key is that you're going to go back and forth as you write this. It's not going to just come out in one perfect flow on the first time. You're going to go and try to tweak it. You're looking for adding in the cause part. So in this classroom, and we say this classroom because we haven't done any replication outside of this classroom. Perhaps the way that I teach makes it really easy for you to do well while listening to music, but the way a different teacher teaches makes you do worse when you listen to music. I don't know that. So at this point, I don't want to make claims beyond my own classroom because that's where the study was done. But in this scope, in this classroom, listening to music caused students to perform better on a unit test. That's what my results suggest if that's how the data came out. Again, we haven't run the data, so we don't know, but let's assume they came out that way. This would be the type of claim I could make. And then finally, last one, we had the political organization studying a link between gender and voting preferences. They collect a set of volunteers, and this was the study that we had the fairly worthless results from. We're not sure exactly what population they come from. It's only an observational study, so we can't find causation. And the study isn't done correctly. There's no SRS involved. So when we make this claim, we can claim almost nothing. The only real claim that we could make is of the people we talk to. So this doesn't apply to any general population, just of the people we talk to, we found a link between gender and voting preference. If you were to publish a result like this, nobody would care because it doesn't apply to a general population. That's why when you do an observational study, even if you can't claim what causes what, you can at least claim that there is a link in that population. So something is linked and maybe someone will come up with a good experiment to figure out why. When you have an experiment, you can not only claim the link, but claim the cause. Here, because you don't even have a correctly done observational study, you can make almost no meaningful claim that anyone would care about. So when you're making your claims, be very clear to state not only what population, let's go back to this last one, what population you are applying your results to, but also whether or not something caused something or something is simply linked to that. So again, be very careful when you make your claims to not overstate.